In this video, I'm going to talk about how we can implement an Akinator clone. If you haven't heard of Akinator, it's this online web application that will guess any character or entity, as I will call them, that you think of. It will do this by asking about 20 yes or no questions that you should answer truthfully or mostly truthfully. So it will ask stuff like, is your character a YouTuber? Is your character a boy or a girl? And stuff like that. And you see if you know some Minecraft YouTubers and you're thinking of one in this case, you'll see that it already, from the first few questions, starts to zoom in on them. So already, how many Texan Minecraft YouTubers are there out there? Well, I don't know because I just answered randomly, but probably not very many. So it's able to zoom in on whatever you're thinking of quite fast. And I will talk about how we could implement something like this ourselves. First of all, if you look online, you might find this question of mine from Stack Overflow from about 10 years ago, where I asked this exact question, how we can implement something like this, because I thought it's a very interesting project, and I still think it is. So, other than this and similar questions, you will not find, as far as I know and as far as I have been able to find, any serious information or exact information on how this could be implemented. But the good thing is that I described here myself an algorithm or the basic ideas of it, and today I have it re-implemented in Python and hosted on GitHub and on an actual website that you can use to play my own implementation. Of course, it's nowhere near as good as Akinator so far, mostly because I don't have a lot of data. This is all data that I have generated myself by playing the game. You can also submit questions and submit entities once you play them. Alright, so let's talk a bit about how we could implement this, and if any of the ideas we can find online are of any help. So again, by reading the online information pertaining to this, you will find ideas such as using decision trees or using a neural network. And I guess this can probably work, but I think the feature space will be very high if you decide to use something like this. And even if they will provide an answer, they will get you what question to ask next, and they will provide a guess at the end. I don't think they will perform very well in practice due to the large feature space. I spent a few hours thinking about how we could maybe use decision trees or neural networks from scikit-learn and just doing a sort of plug and play thing where we fit the models and then call predict on various things built on what the user answers to the questions. But I couldn't convince myself that they would behave very well in practice, so I decided against using a scikit-learn model, even though I do think it would be very cool to do it like that, to just read some user answers, plug them into a model from scikit-learn, and output its predictions. If you have any ideas on how that could work and how it could work well, please let me know. I'd be very interested in doing it that way as well. But because I couldn't figure out a way of doing it that way, I came up with this approach that uses 6 main tables, database tables. I use an SQL database in my implementation that I perform queries on, and those queries get me the next question to ask and the prediction at the end. So first of all, we have a questions and entities tables, and they will store the questions that we know so far from the people who have submitted questions, and the entities that we know from the people who have played them. So straight off we can tell that this is a user-driven application, because the users will provide the data and the algorithm will learn based on the people that play our game. So this means they can input bad data, they can corrupt it, so to speak. So hopefully you don't do that if you use my implementation, because so far I do not have a moderation system in place. But of course, if this grows, I will have to implement one. Okay, so once we have the questions and entities, we need a way to relate them. And that is done in the questions entities table, where for each question entity pair, we have counts for each possible answer. So yes count tells us in how many games in which this entity and this question were played. So basically this entity was the correct answer and this question was asked. How many times the user answered yes. And that's considered correct what the user answers, and it gets counted here. So if most people answer yes, then question 1 in relation to entity 1 has a known or assumed correct answer of yes. So basically we trust the majority of our users. And it's similar for no and unknown. Next, we have a games table that stores our games, a games questions table that stores the questions asked in each game and the answer given by the user. And finally, we have a games entities table that stores for each game all the entities that we know and their score. The entity with the highest score at the end of the game, so after asking 20 questions, will be what our algorithm will output as its guess. So how does this work? Well, let's say we ask question 1 and the user answers yes. For question 1, yes is the majority answer for both entities. So both of them will get their score increased by 1, and it's 0 initially. Next, let's say we ask question 2, and the user answers no. No is the majority answer in relation to question 2 only for entity 2. So only entity 2 will get its score increased by 1. So if that's all we have so far, entity 2 will be the answer that we will give the user. And of course the user can say whether it's correct or not. They can add a new entity if it's none of these, and so on. Those are details that aren't central to the algorithm. So we described how we get the answer, how we build it up, but we didn't describe how we choose the questions. In order to choose the questions, we will use something like a binary search. We want the question that splits our entities, our considered entities, into two sets regardless of the answer. So whether the user answers yes or no to the question we're about to ask, we want to increase the score of about half our entities in the ideal world, in an ideal setting. That's not always possible, but we want to get as close as possible to half. And that's done using Shannon entropy. So we will use Shannon entropy to pick the question that has a majority answer of yes for about half the entities and the majority answer of no for about half the entities, for about the other half of the entities. An entropy close to 1 will give us that. If it's 1, it's exactly half-half. As lower as it gets, it's more unbalanced. So they're either all or most of them yes, or all or most of them no. And generally we don't want such questions. And that's the gist of it. I also thought a bit about using information gain here, since that is what is used in decision trees, and I wanted to sort of replicate that mechanism. But information gain also requires that you have labels, and as the game is being played, I couldn't see what the labels would be in our case. So I decided to just use the simpler Shannon entropy. And it seems to work quite well in practice. If you play around with this implementation, you will see that it does quite well. After you add new entities, maybe add 1 or 2 helpful questions regarding that entity, it will start to guess it quite easily. So I encourage you to play around with it and see if you like how well it behaves. The code is also quite simple, although there are a bit many edge cases, so to speak. There are things that aren't immediately obvious when you think about an algorithm. It's very easy to decide that this is a simple problem that's not really worth pursuing an implementation for. But once you get down to writing the code, you see that there are many things you need to think about and take into consideration. And hopefully I've managed to come up with decent solutions for most of these cases. So the code is written in Django for the backend with Django REST API, and in Angular for the front end with Angular Material. It's quite easy to understand for a beginner developer, I think. I've tried to organize it decently. Not great, but decently, I think, for the amount of time I spent on it. It can definitely be cleaned up a bit, which I will do if this gets a reasonably sized community behind it. We use Django's ORM for some of the queries and pure SQL for some others. I found that for some things using pure SQL significantly improves the running time, so I opted to do that. I've also written how you can get this running on your own machine or on an actual server if you want to deploy it somewhere. So I encourage you to take a look at it. Let me know if you have any questions, any suggestions. And I hope you like this game. I think it's a very interesting project. It involves algorithms, it involves software engineering. It was very fun to do. And there's plenty more to do in the future if we will get some people playing this game, because as it's written right now, it's not very efficient for many players. If we take a look at Akinator, if we go to its homepage, you can see that there are about 1,000 people playing right now, with many games played today almost. a billion games played today. Well, not today, sorry, this is in total, but 73,000 played today. So if we consider this algorithm where we copy all of our entities for each game, that's going to kill our server very fast if we have thousands of players and thousands of entities. If we have, let's say, just 1,000 entities and 100 players, that's already 100,000 entities, assuming each player plays just once. And they will probably play multiple times on average. So that's definitely an interesting optimization problem, whether or not we truly need to copy all of the entities here, or if we can do something smarter than that. And I have a few ideas about what that something smarter might be, which I will discuss in the future if the need for such optimizations presents itself. I hope you've enjoyed this video. Leave a like and subscribe if you have, please. Thank you and see you in the next one.